Cool. Testing the levels. Should have done this beforehand. Testing the levels. Okay, that's looking good. All right. Good evening, everyone. This is yet another iteration of the stream where we work on ScummVM, namely ScummVM's director engine. Continuation from last time when we were basically adding in a whole ass debugger into ScummVM to replace, I guess, using GDB to interrogate the scripting engine part of director. We got pretty far last time. We added pretty much all of the step functions that we need to make, as well as some of the kind of basic functions for kind of interrogating the stack and things like the script frame. I've been good. I haven't really touched this very much since the last stream. There was one kind of sort of head-slapping realization, oh yeah, I should have done it that way moment after I left last time. It was this one here. So for finishing, which is to say the step, so normally you just want to either go between, when you're stepping around your code, you want to go like just one step plus into function calls, or just one step and over function calls. That's what step and next are respectively. And then there's finish, which is basically just skip on ahead until you get to the end of the current function. And I did it by kind of putting in a separate hook at the end here, like specifically for measuring the finishing state. What I didn't take into account is that the way that we execute Lingo here, we've got this one loop, and you'll see here that it's kind of just a while loop, and it just kind of checks to see whether or not this pointer plus the program counter is like the emergency stop frame. What I didn't take into account here was that when you do a function call, this gets mutated. So there is absolutely no recursion, and if you do a function call, it will just come back here and go up and around. So therefore, my assumption was that, once you've broken out of this loop, we're clearly at the end of the current function. No, it will just keep going. So really, so we have a step hook here before the current instruction that's being executed, and then one just outside here, which is basically just after all of the scripts have returned. And the interior logic of that is still, we just have a counter here, which just counts how many times we've been... it's sort of similar to the kind of the next counter that we were working on. So I'll just scroll down here. We have like these push context hook and pop context hook, which, for lack of better terms, means every time we step into a function call, counter goes up. Every time we step out of a function call, counter goes down. And then we use that to kind of realize whether or not we are either, we're on the same level of code if we've stepped over a function or not, etc. Anyway, so finish basically uses that, but we're not checking to see how deep we've gone, we're just checking to see if we're about to go up a level. And if we are about to go up a level, then that basically means, if we're about to go up a level, then it's a finish, and we should hit the brakes. Okay, so let's go back to our kind of big list of cool stuff that we're definitely going to want at some time in the future. There's a lot of things we can work on just off the bat. I'm actually tempted to go for this one first. So this is another kind of function which would be really nice to just have from even when you're using with GDB, like it is possible to kind of put in a conditional breakpoint specifically for if we hit a certain frame in the movie, but that's sometimes kind of a little more difficult than it needs to be. So I reckon we'll just so we can warm up, because it's a marathon, it's not a sprint. Gotta pace ourselves, so we're just gonna pick some of the more easy, low-hanging fruit first. And so I reckon we start off by implementing this frame instruction here. Okay, so first thing we need to know is where exactly that is defined. I'm pretty sure it is part of the score. Score in director is basically the actually I can you know what? Let's open up director so we can point to some of these things. Yes. Also, I did notice last stream that my camera got very badly out of sync. I think it's I was looking it up last night. Apparently, there is a NVIDIA bug which is caused by having, well, I mean, it's to do with updating the screen and forcing VSync, but apparently it's made worse if you have a mouse which is like a gamer mouse, like a mouse that updates like 1,000 times a second as opposed to 100 or whatnot. So I've tweaked some things, so I'm hoping that it won't go out of sync today. But yeah, if it does, not much I can do about it, unfortunately. And okay. All right, I'll just open up a movie with something in it. Oh wait, no, that's not a cool one. Yeah, this one. Okay. So like this is the movie that I use for that I was using for testing like palette fading effects. So short trip around director, like up here we have the cast, which is effectively all the resources in your film. So all your sprites, all of your videos, all your sounds, etc. Which you can then kind of lay out here on the stage. Because yes, everything in director has got a very, Hollywood / filmmaking inspired name. Down here we have the score, which is sort of like an animation running sheet. So you can see here that like we've got pretty much every column is a different frame in the movie, and every column is like a different frame in the movie, and every row, I've forgotten what the word row was for a second. Every row is a different type of resource. So these numbered ones down there are cast resources, which means you can they're basically channels. So we've got like, I think in Director 4 you get up to like 48 different cast members or channels on the screen at once. With the exception of sound, you get 2 sound channels. You get 1 script channel, which we're probably going to get into a bit later on when we talk about scripts and what scripts are accessible from where. You get the opportunity to like set like a cheesy transition, like a PowerPoint style transition between each frame. You get palette transitions, which is the thing that I was actually testing in this set of movies here. So I was just testing the fading effects from for like this. Yeah, Director provides you with this kind of cheesy rainbow palette that you can use to test like color fading. So I think if I hit play, yeah, you can see there that it just kind of transitions, the colors rotate along the width of the palette. Anyway, so yeah, palette effects, and then this one here is more about like timing effects. So okay, again, similar to PowerPoint, you can do things like you can trigger the like a mouse click being the things like, will a mouse click be the thing that goes to the next frame? Will it be a script? Will it be a key press? Will it be waiting a certain amount of time? Short version is PowerPoint probably stole a whole bunch of features from Director. Just guessing. Don't quote me on that, but probably Wikipedia is a better source. Yes. All right. Anyway, there's a little tour of Director. So we'll go back into here. So score.cpp is the module which deals with the score, which as we just kind of discussed, is the timekeeping bit at the bottom. So yes, we have here. So we have here 2 variables, current frame, which I believe is the index of the current frame that we're on, and next frame, which is used in a scripting context to indicate what the next frame should be. Like for instance, if I jump to next frame in the code, we've got yeah, so we've got like set start to label, which is basically a way of turning, like you can name individual frames. You can give individual frames a name. So I don't have any of those in here, but if I open up another movie that does, if I open up the CompuServe one that I was messing around with, that has a bunch of name frames. So you can see here, frame 6 is named hello. I don't know, the author of this movie was like smart enough to put in little put in little comments essentially on each of the frames whenever there was a audio sample being played.
Hello. You know this place.
Yeah, exactly. So anyway, that's what a label is in the context of this. It's basically like, this is a function which looks up the label, tries to get a frame back in return, and then if it does have that, it sets this variable next frame. So I'll see if I can find the actual, yeah, again, like go to next and go to previous. So these are the methods which I think are called by the Lingo scripting stuff for going to the next or the previous frame. Like if you asked for that in the script, it'll basically just set next frame, and then there should be I think it's this update one. Is it update which yeah, okay. So yeah, when this score update method gets called, it checks to see if the next frame has been set to anything, at which point it sets current frame, it increments current frame, and then I believe it does all the stuff it needs to do to to move the current playback head. Any old way. That'll become important later when we need to do the extended version of this, because we want to be able to get or set the current score frame. So the setting is definitely going to have to be done in here. Now, that's right. We've got to do the boilerplate. Wouldn't be a proper debugger without loads and loads of boilerplate. So the after version. So get that. Just nick this. So argc2 would be the case if we get a second argument, which will be the number of the frame that we want to set it to. So I think we'll just pinch this. Then I believe what we'd want to do is we'd want to go G director get current movie get score set. What options do we have? We had a few options, I think, for setting next frame. It'd be nice to use the one that's already there. Go to next. Oh, we don't have one which just does a cheeky set of next frame. Oh, it could be that we do it a bit nastily. Apparently not. Which makes me wonder, we should probably do it the same way that Lingo does it. So Lingo built-ins, go. Yeah, so the command in Lingo to switch between either a frame or a movie is basically go to 3 or go to movie name or something like that. Or go to next if the aim is just to go to the next frame. Okay, func go to. So okay, so it gets the score. And it gets the stage. Oh, I see. Okay, so first this function is yeah, okay, makes sense. So we set because this function needs to be able to deal with the movie changing as well, so that's why we're getting the stage, because that's the level which you need to switch out the movie. So basically switches out the movie using the stage, then it... Oh, there is one called set current frame. You know, we could just use this. We totally could, actually. I mean, we could. Just then, yeah, then we have to like pull in like all of this datum stuff, I believe, that we don't do already. Oh no, we already pull it in. It's fine. It's normal. Okay, so if we are going to use this, we will have to detect. So we'll use A to I to detect if the argument that we send it is an int, and if it is an int, we'll send it a datum that's cast to an int. Otherwise, we'll just send a datum that's cast as a string. That seems like it would work. What's the name of that? It was funcgoto. Oh, wait, yeah, it'll be part of the... Oh, wait. What's the argument? Oh, first argument is frame. Okay, so we can't... Oh, I see. Okay, so we'd actually need to move that into sort of datum frame. No, easy way of doing it. If a2i v1 is greater than 0. Oh, yeah, okay. Fine. I guess C++. And unless I'm much mistaken, that should make a string. Oh, okay. No, we need to make a. Yep. So that one should be either an integer or a string. That should be just a. That should just be not void by default, which then I think means we can pass that to there. And then, yeah, for the no arguments case, we just print what the frame number is. Again, I'll defer to how Lingo does it. It's probably better that we keep things consistent. So I think we'll go Lingo the. Get current frame. Oh, sorry. Should we get get stage? Oh, because I'm not referring to the right. Because I need to add more things here, I think. Is that it? Oh, director window. Oh. Who would have thought? It's in window.h. Oh, okay. What was I looking at then? Oh, it is get current movie. Yeah, okay. My bad. My mistake. And now it's gonna whinge that it doesn't have that information about that. So oh. Oh yeah, okay. All right, that's in. We just need to add a command for it. Did I miss anything? No, that's there. That's there. It's got all that. All right. Let's assume that that's good. Oh. We don't have the CompuServe demo in this list. I should really add that.
Hello.
Oh no, the theme's changed. It's now text for ants. Oh, there we go. We can just make it bigger. Right. Okay, so we're on frame 19. And if I wanted to jump to like later on, such as, oh, what's an interesting frame? We can check here in DOSBox. Where's the one with the big counter? We'll go to this one. This frame 140 is the one with the electrical socket. So we'll go F140.
How do you get global?
Yeah.
Millions of people are already there.
Cool. That seems to be working. So I'm not sure whether or not like eventually, right, we're going to make like the ability to put a breakpoint in, which means that we can accelerate on ahead until we hit, say, like a particular frame. So it may, because I mean, if you set a frame in here, like nothing happens until you leave the debug window, and it might be better to actually just scoot on ahead, similar to how we do with the step features. So okay, that gives us an idea of what we should work on second. So frame, we've got working. I think we should maybe add a step, yeah, like this next frame. So not quite a debugger, but it's still important nevertheless. So we'll add in more boilerplate. Oh wait, that comes there. So we'll basically just we'll be doing exactly the same thing that we're doing in here, effectively, except it's now a frame counter. Ooh, something else we gotta add. We'll call it next frame, so as not to be confusing. Add in another counter, which is going to be just so that we can either just go NF once to advance one frame, or NF and a number to advance many frames, and this will be tracking how many frames we've gone so far. So we're going to need another type of hook. So oh, now gotta define that too. So do that, and of course we've got to call the frame hook when we switch to a new frame. Which I believe will be when current frame goes to next frame, so it would be here. Because I mean, oh, okay, yeah. So, what's it doing? Oh, okay, this is the code to kick it over to the next movie. It's probably here. Yeah, it's probably here where we've got the little helper to say what the current frame is. Yeah, because the main thing is we need the hook to happen before this, because this is basically the prompt to run any scripts that are attached to the frame, and we want to be able to intervene just before that happens. So I'd say you just pop that in there. That looks there. That looks fine. Oh yeah. Got that. Got that. Seems legit. Oh, that's right.
Hello.
Okay, so let us try and advance 10 frames. Oh, sorry. We'll advance 1 frame. That seems to work pretty good. NF10.
It's big. It's moving.
NF100.
It's never the same. How do you keep up? How do you get global?
That's pretty good. I'll just check 161. Yeah, 161 seems to be that. Yeah, the counter. Cool. Alright, better commit what I've got. Actually, where I put in WIP? Oh, I put in all this. Yeah, I put in all the extra stuff. Okay, that's fine. Cool. Okay. All right, next movie. Oh, we can hold off on next movie for a little bit. I imagine that would basically use the same hook. We just have to. Oh no, we could put in another. We can put in another hook during that. No, not that. In the score. Oh yeah, we couldn't, yeah, if we do that, we can't really put, yeah, we can't use this because you can see that, like, what happens is that the score will set the next movie, it will kick it off playing, and then it will return, which will then pass control back to the stage. So we can't actually use a hook in score. We would need to make a separate hook in stage. But that's fine. Let's stick around. Let's keep doing stuff in score. Channels, I think. So we already have, yeah, this is like another case where we've already got like a printout for this in the ultra verbose logging output, but we could put it to better use by making it a debugger special. Okay, and it's in frame.cpp. This armrest is just like a tiny bit too big to fit under the desk, which is not ideal. Where was I? Oh, that's right. Here we go. So I reckon this is too useful to just keep around in the special debug output. So I think we should make this another public method on frame to give us the cool stuff. What did I say we should call it? Channel, yeah. Okay, how are we doing this? Oh, is it because we were doing this in a loop? So we have all that. Oh, we don't have to do it in a loop. We're pulling stuff from Sprite. So we can just do that the normal way. So let's start off by just copying all of these. Yeah, so to put things in perspective, if we look back in the score, you can see here how the way that the score is laid out, we've got tempo, palette, transition, channel, sound 1, sound 2, script, channels, and that is the order which we have this debug output here, which tells you basically all of the particular channels in a current frame as you'd see it in that score window in Director. So we should be able to just steal all of this, place it in here, and then start. troubleshooting. Oh yeah, we need to add new lines to the end of this. Else it's just going to be one big string, which not ideal. Okay, and then finally sprites, which I think we're gonna have to just do the same way that we do in there, which is we just take a reference to all of that stuff. And once again, rip out the debug strings, or rip out the debug method, replace it with string concatenation, and add new lines. So now we should be able to what was the name of that call which checks to see if you're the right debug level? Yes, debug channel set. That's what I'm after. And we're doing this just so that we don't have to generate the string if we don't have debug mode on. Then means we can throw this out and throw this out. Format string is not a, oh, yeah, okay. All right, you got me. Cool. So we've modularized that, which means back in here we can do channels. Do we do? Yeah, still got to do a boilerplate. Oh. I'll just nick this. So I think we just want to leave early if there's no actually no, we'll do the good case in here and then go. So if we don't specify which frame we want to do it from, we have to go one and whatever it was. Score. Oh, it's a typo. Actually, maybe we want to. And it's going to whinge about it being unsigned. Yes, it is. how's this gonna work? Because I know that in Director all frames are 1 offset rather than 0 offset, which would mean that if you've got, yeah, okay, it would be up to and including the size. Okay. Oh, yeah. Maybe I meant to do that. And I also got to define what frame is. A fair criticism. A fair criticism. What? Still unhappy? Oh, because I didn't... Okay, that's on me. Okay, where... Oh, yeah.
Million.
Oh, wait. I started too soon.
Hello. You know this place. It's big.
Oh, wait. Yeah, okay. Oops. Yeah, if I... Okay. I just remembered if... Yeah. If I don't give an argument, it should just give me what the current frame is. I shouldn't have to, like, type it in. Oh, wait, I'm already here. Pretty good. It's telling us pretty much everything that we need to know. That text overflow thing is a pain, but we can fix that another time. I'm not too fussed about that. What I am... Yeah, we should do it properly while we're here.
Hello. You know this place.
Okay, so let's just jump to frame 160. Then give me... Huh? Oh, because of that. Because of that. Okay. Oh, and this is... Yeah, okay. That's a memory crime. First memory crime of today's session. argv1 may not exist. I'm just assuming that it does, and it is probably operating on a null pointer when I did that, and that is not good. Okay, better way of doing this. Make it that by default. That should do it.
Millions of... Hello. You know this place. It's big, it's moving.
Oh yeah, and now that we have, yeah, okay. I just realized, now that we have the next frame feature in, we should be able to fix frames so that it leaves the debugger properly. But anyway, we'll get to that soon. Yeah. Okay. Looks good. Ooh. Still a memory crime, huh? What did I wreck? Oh, it was a lingo thing. Oh, right. I think. What? So we've hit memory crime number 2. But what kind of memory crime?
Hello. You know this place. It's big, it's moving, it's never the same.
What did I do? Oh, that's right. I set the frame to 160. Then I did NF.
Millions of people are...
Okay, so I'm in a script now. I'm pretty sure that's what I'm not allowed to do. So if I go F180... No, I'm allowed to do it. Ah, there we go. Okay, so what broke? I'm going to CPP 457. Oh, is it because current script? I don't like this. This doesn't give me a good vibe. Okay, PC is 0. And current script is a null pointer. Okay. Seems slightly problematic, but not the worst thing in the world. I mean, it should be busting out of there if it's a null pointer. I would have thought that by using the script methods we'd avoid race condition things. Ah, but you never know.
You know this place. Millions of people are already there. Tapped into cool places.
Come on, script. There we go. Now jump back.
It's big. How do you keep up? How do you get global? Millions of people are already there.
Well, it doesn't seem to be dying like it was.
Tapped into cool places. Hello. You know this place. It's big, it's moving, it's never the same.
Okay. Given that kind of jumping around like that is always going to be a bit of a dodgy behavior, I think that's good enough. Like, if something bad happens and current script gets set to a null, I'm okay with that. That's preferable compared to being set to a pointer that gets invalidated. So let's cautiously say that that's a good thing. I mean, it's an assert, really. So like this should never reach, or what do you call it? If it becomes null, this by default is a memory crime. So we have to put in a guardrail. That's it. We're just putting in a guardrail. Don't think too hard about what we're doing. We're just putting in a guardrail. I think we're good to go. Cool. So that's channels out of the way. What do we got left? We have cast. Cast would be a good thing to put in. We don't. Oh, we do technically have something in the verbose debug flotsam for cast. It's just very it's intermingled with other stuff, but we should still get that looked at, I feel. we'll do cast because that's like the final easy one. Then we'll go on to funks, which is going to be a bit of a pain, but we need it. So such as it is. Okay, that's good. Was it after channels? Yeah, it was. So I don't think we need lingo. Oh, do we even use lingo in here? Oh, okay. That's embarrassing. It's really, I should go back and amend this so that it's not messy. One moment. Yeah, that's how it should be. So what do we do? This. Oh, yeah. Gotta get out of that. One thing I slightly glossed over when I was talking about the cast up here. It looks like there's just kind of one big continuous list of like thousands of, well, you know, up to 1,000 or so items. But what you can actually do is you can make a movie in the same folder called shared.dir, and those, I don't know what you call it, the cast members in that movie get, I don't know, it's a way of being able to kind of make a so-called shared cast. So this is useful for things like common scripting pieces, icons, bits of UI, etc. So you don't have to keep a copy in every single movie that you make. You can just make a shared cast and it'll merge it in with this list here. So it is, yeah, so here when we're listing all of the cast members, we're going to have to fetch the cast and the shared cast and list them both individually. Possibly in Director 5 and up, this could get messy because we don't have one shared cast. We have multiple, or we have different libraries, but we're only dealing with Director 4, so it's fine. Everything's fine. So remind me, what methods we got? What methods we got on our cast? Right, I see. Yeah, we have, yeah, okay. Got cast members stored in a dictionary thing. Text members stored in something else. Script IDs. Names, which are their own thing. Alright, here's how I think this is going to have to work. I think that we're going to have to get the list of keys from this hash map. We're going to have to sort them. We're going to have to... And then, yeah, from there we would need to annotate each of these cast members. Possibly we can make a generic top level method on cast member which would describe what it is. This is sounding like slightly more work than I thought it would be, but that's okay. Okay, yeah. So yeah, we've got cast member as the base class, and then individual specialty ones for bitmaps and videos and film loops and movies, all of that. Which makes me wonder, well, first off, do we even have a method which allows us to cast between this and a string? I'm gonna guess no. Oh no, we do. Cast type to string. Okay. What was the thing? Okay. Was it loaded cast? And it is public, okay. This is another case where I'm going to have to check what you actually get in hash map. It's got to be, yeah, it's got to be something they had to iterate over keys. contains... Oh, just tell me all the iterators. Oh, right. I see. Okay. So does that mean that... Does the ScummVM array class have the ability to sort? Okay, it has sorted array. Let's do a C++. Oh wait, do I... Sometimes my mind goes blank and I can't remember the C++ cast. Yeah, okay. It is that. Oh, and there was a shortcut. There was a shortcut for good iterators that you can do in C++. That is allowed. What? Oh, right. That just sorts a list like that. Okay, I can't see what I'm looking for. It was basically we'll just do this the normal way. Yeah, this would be a pointer. Oh, yeah. No matching constructor for initialization of... Oh, yeah. Oh, it is a pointer. Okay. first. That'll do. I'm sure there's an easy way to use sorted array, but that can be for someone else to refactor later. Okay, so we have a list of cast IDs. At least I think it's cast ID. Unless it's not. Unless it's... Oh god, now I'm paranoid. I'm paranoid that it might not be that. Because I know that the thing we want this thing, this, which we can get. You know what? Oh, we can, but then we're going to map it back. Maybe what we want is a tuple. Yeah, maybe. Okay, let's. The smart way of doing this would be with a tuple. So I am very sorely tempted to just use a tuple. Okay, no, the key. All right, so the key is the cast ID. I think, yeah, it's got to be that. Okay, good. Assumption turned out to be correct. So we'll keep this very basic to start with. We will use that util method that we had, cast type of string. type. Oh. Hmm? Oh, because... Hang on. Hang on. Oh, because it's dereferencing the damn pointer. How about now? What? Oh, yeah, that's me. It would be nice not to have to kind of repeat stuff. Whatevs. Can be refactored later. It just occurred to me, maybe why are we doing it all in here? Like, we should make a method on cast. Yeah, we should make cast. Make a method on here. Similar to what we were doing before. Keep all of the kind of nitty gritty internals out of the debugger. Let's say format cast. What's the correct method for getting a cast member? The one that isn't just... Yeah... Let's get... Oh, just get cast member. Easy. Left operand of comma operator has no effect. Oh, because of... Yeah, okay. Come on. Because I need to format it. Okay. That's looking good. That's fixed that messiness issue, which is good. It also means we don't have to have any of that stuff in the debugger. We can just inject it all here. This is good. It's getting meatier. It's getting a bit meatier every single time. So we won't be able to see very much to begin with because all we've done is just get it to show the cast list and what type it is. It's also going to be very, very big.
Hello.
But it's always going to be very, very big. So we can scroll on here. Cast. What? I didn't wire it up. I didn't wire it up. Channels. Okay. Hey, all right. That's looking good. And yep, that should match what we've got here in DOSBox. So number 16 should be a shape, which it is. It's an oval. 21 should be a shape. 33 should be the Ford logo. Yes, okay, good. Do any of these resources have names? Oh yeah, we do. We've got a couple of names here. Okay. So the next thing we should really add is, next thing we should add is names, because that is relatively straightforward. Cast. Yes. So how are the names kept against each cast member? They don't look like they are. I think that just seems, that's just a cast library thing. Cast's names. Okay, maybe it's just put into... Oh, I see. Oh, okay. So I think, cast names is just like the lookup table that we use or that we generate so that scripts can look up things by name. The canonical source of truth is in this cast info struct, which we can get from the cast using this, I think. Or just get cast member. That'll work. So how do we present this? I guess we can just do like number colon string colon. Or we could do number square brackets. That's also an option. Just how we see it. I mean, most of these are quite... Yeah, so if we do like 169... Actually, no. What options we got? We got... Oh, because it's a string. Let's see how that looks.
Hello.
Oops. I did another memory crime. A bad memory crime, too. Yeah, that'll do it. That'll do it. I think that works.
Hello.
Yeah, that's not too bad. Not too bad at all. Okay. So, yeah, the next logical step after this would be to go through and like go into some of these cast members, create maybe like a better kind of detail. I'm just trying to find a good example. Yeah, like this, for instance. This may be like a bit too verbose, but just go through, make a generic top-level method on cast member, which is basically like format contents, output useful things like frame rate type, etc., so that we don't have to go through the verbose logs to get that info. But for why is there 2 pluses? Oh, because I'm still in... Am I still in, like, apply mode? Oh, I'm not. Just tidy this up. Okay. So this has been good so far. We've done like a lot of low-hanging fruit, a lot of easy stuff. But sometimes life is difficult. Sometimes you gotta grasp some of the more complicated bits. In my mind, that means I've got a choice between this function list one here and this disassembly one here, or potentially these breakpoint ones here. I'm not sure which one to pick. It's hard to pick. We'll have a quick look at this. We'll have a quick look at getting all the functions. Now this may be slightly harder than expected because there are so many different sources. There's like the big built-in list, there is the list that comes with the cast, there are per frame ones that get applied. I'm gonna have to refresh my memory as to how that all gets set up. Yeah, so like init built-ins, init funcs, init bytecode, and that's in a different file, of course. Okay, so like as an example, this is the big list of built-in Lingo functions. It's mostly just, like math expressions, string concatenation, etc., etc. And these are all part of the. You can look through the Lingo guide and see all of these, like, etc. But what we care about is that when we start ScummVM, it will go through this big dictionary up here, which is basically the mapping of functions to function, function names to function pointers. It'll go through that. It'll convert them into symbols, which is the lingo internal representation for a function object. And it will stick them into built-in funcs. C built-in, F built-in, H built-in, and K built-in. What's K built in? Oh, constants. K for constant. Oh my god. All right. Oh, okay. Is F... I'm drawing a blank as to what the F means. Okay. Built-in command, built-in function, built-in handler, and built-in constant. I see, okay. All right. And then we have handler, which is user-defined things. So this, yeah, okay, so if that does all built-in funcs, what reads from built-in funcs? Is this call? It is call, I guessed correctly. So the way that call figures out if something is a function. What have we got here? Okay. So okay, these are like args that get passed. Don't care quite as much about those. So it gets the function symbol from get handler. Does that mean it just doesn't do built-ins at all? Doesn't care about built-ins? Oh no, it does. Oh, I see. Okay. So it tries getting it from get handler, then it checks built-in funcs and built-in commands. All right, next question. Where does get handler get all of its cool things? Get handler is defined here. Current script context function handlers. Yeah, okay. Makes sense. Makes sense. So on top of there being built-in functions and built-in commands, there are two types of user-defined functions. There are the kind which are attached to a frame, which I believe is this current script context stuff here. And then there are movie scripts which are attached to the entire movie, which I believe are grabbed from here. So I just need to okay. Let's start. Let's start and add some stuff as we go along. Script frame. Oops. What am I doing? Bad Vim time. There we go. Let's say frame functions. What was the, how did I put it before? Not found. Hey, Arvinla. We are currently trying to print all the functions. And we're getting pretty close. So I think, yeah, so these are all the ones that are just attached to a frame, and these are the ones that are attached to the movie. And oh, useful. Okay, so it's just a dictionary. Symbol hash. Oh. We have something called function names. That might even be more useful. Where do we define script context? Yes, printing all of the functions, or just at this point, just printing all the names of the functions. We can get into the meat of it later. The real thing is, yeah, we just want to get those. What's it called? Get the symbols, so then we can then extract the stuff from inside the symbols. So, where was I? I see. Okay, yeah. That's fine. Oh, good. The camera's working. Sorry, thought it was busted for a sec. There probably is going to be a little delay in broadcast because I am in Australia and it takes ages for the ones and zeros to go through the pipe. We got like this looks like it's worth using. I just want to check what it's for. Or rather, what me from 2 years ago made it for. Oh, okay. No. It's, yeah. This is sorry, this isn't just like a generic list of function names, which I thought it was. It is actually a lookup table. It is a lookup table between an ID number and stuff in a script. So yeah, don't mess with that. That's not what we want. The thing that we want is open too many source files and my object permanence goes right out the window. We need function handlers. So I think the best way forward will be if we iterate through this, generate a big list of names, and crack on that way. Did I mess that up? Oh no, here's a pointer, okay. All right. Oh, yeah, sorry. It would be key. Except, is it a pointer? It's a pointer. It's a pointer. Let's try that so far. Because that should be enough. Should be enough to test with. The introduction to the dev environment. Yeah, okay. There's not really a lot to my dev environment. There's no fancy IDEs or anything, so really what I have here is I have here a GNOME terminal session with a bunch of tabs. One tab, I've just got the build queued up, so just ScummVM with just the director engine and ASAN, so like the memory sanitizing stuff. And then in other tabs, I am either just using ripgrep to just search through files, or I'm using NeoVim to edit the files. And yeah, it's NeoVim with a bunch of plugins like COC for code completion. I've got like this is the C++ one that's running now. That's what's kind of giving me all of the information. I think airline is this tab thing up here, and various other NeoVim stuff. Yes, always with address sanitizer. If it was, it's pretty unintrusive, like compared to something like Valgrind. In the bad old days when you wanted to do like memory leak testing, you have to run it in Valgrind, and Valgrind feels like it's 20 times slower than just running it normally. ASAN, by contrast, just does lots of fancy stuff with the memory allocator and guard pages, so it takes a little longer for the execution to start, but it's much better, and it gives you just so much more context. Like normally if you just screw up or like do a use after free or something, if you're lucky, you'll get a segmentation fault. If you're running in GDB, you might even see where it crashes, but ASAN will tell you where you messed up, as in like where the memory was allocated, where it was freed, which is just, yeah. In this day and age, you really want to just be building with ASAN all the time. And yes, in here I am running ScummVM in GDB. We all love GDB on this stream. We don't love GDB, that's why we're trying to get rid of it. But it is pretty much the only game in town when debugging C stuff, especially under Linux.
Hello.
So we're stuck with it. Okay. Okay. I'll just
this place.
Scroll forward until we get to a script.
It's moving. It's never the same.
There we go. So now we're in a frame that's guaranteed to have at least this exit frame thing attached to it. So we should be, oh my goodness, funcs. Hey, yeah, and there we go. Notice that we have the function exit frame, and if we continue on until we're out of that, and then we do funcs, not found, which is good because we're no longer in a frame which has local functions attached to it. Okay, that's good. That's the first half done. Now the second half is we've got to attach these ones that are attached to the movie. Do I have the movie C++ file open? I do not. We're testing with the, we're just testing with the CompuServe demo today, just because it's useful for kind of like, it's a fairly long movie, so you can see in here we've got like 700 frames, and earlier on in the stream we were testing the frame skipping function, so like we can see now that we're on frame 75, and if we skip to like frame 300,
or not. New keys to compute.
That works. We can skip behind.
And
it goes back to the beginning.
It's moving.
Except it's now kind of crazy fast because we changed to a different frame rate. Stuff like that. Yep. So, yeah, all up, we've made good progress. still haven't touched the breakpoint stuff there. We might have like a little go at the end of the stream. The key that we want to get, the main thing that we want to kind of get done now is this functions list. So one of the things which I think I might need to give a little bit more of a think about is how we deal with, so like to put things in perspective, like I'll skip to, so you can see here that like the frame functions here, like we've got exit frame here as a frame function. When we're setting a breakpoint, I imagine we want to either be able to set a global one for if exit frame gets called, kick us in, or something more limited. So like if exit frame on frame 50 gets called, exit in there. So that in turn is going to require like a little bit more thinking about how we define things. Because initially I was thinking that it would just be a case of saying we want to break on like script cast member 200, for instance, which could, or function X in script cast member 200. But realistically though, if you're debugging if you're debugging like this, you may not care about, or you may not know what do we call it? The mapping between like what script cast members get attached to which frames isn't obvious. That is something that we're either going to have to print out, or we're going to have to make it so that you just don't need to worry about it, because you can just set a proper breakpoint to hook into that. And the other thing that kind of springs to mind is that maybe we don't even need to worry about doing breakpoints for individual scripts, because as far as director is concerned, it just sees that there are these, there's a big list of function handlers, and you can, maybe we should just make it so the breakpoint gets put onto the function names as opposed to, individual cast members, for instance, or, functions that are defined in a cast member. Like that seems kind of less useful. Well, I mean, it could be that too. Sorry, yes. So the next step, obviously, actually, you know what? Before we do breakpoints, we're going to do the disassembly one here, because yes, ideally, you'd want to be able to like list the functions, pick a function, and then disassemble it and say, okay, this is the bit that I want to kind of stop at with a breakpoint. You know what? Yeah, we'll continue going on with funcs. I'm tempted. Yeah. Like, that's the thing though. So like there's exit frame that's attached to this, there's this function attached to this frame, but is that the best way of displaying that piece of information? Because I mean, we could just make it scrape through like every single function in the thing, and you'd get like 30 different variants of exit frame, and you wouldn't really know which one to pick unless it also listed them there with what frame they're attached to. And I'm unsure whether or not the best way of kind of conveying that information would be listing all the functions at once, including which frame they're part of, or having the ability to, I mean, like we've got, like one of the other functions we haven't like put together yet is movie info, which I believe would show some information about each of the frames, and possibly that might be where we put the information about what functions are attached to which frame. Anyway, that's that's a problem that's going to require some thought. So I think keep the momentum up. Let's continue on. Let's not think too hard about things. Thinking too hard is death. Disassembly. Oh my god. My object permanence is really bad today. Like, if I talk about something else, I completely forget what I'm doing. Of course, yeah. So we need to do the global list of... Yeah, we need to scrape that list of global handlers, which I think would be in here, in movie. Okay. Okay, so we can just get it through from cast and shared cast, which we're already doing. Let me shut a few of these. I didn't mean to shut all of them. I just wanted to shut a couple. Just a couple. Movie.cpp. What do we got here? Function handlers. Gonna have to do the same thing. Symbol hash. Let's see how that goes. If that works, we'll just copy it for the shared cast member. So we've done that. Get out of here. Start it again.
Hello. You know this place.
Skip to a scripty bit.
It's big, it's moving. It's never the same.
Funks. Hey, okay. Right, okay, yeah. And these are, okay, with one exception, these are pretty much all just handler named functions, which is, it's understandable, but yeah, it's misleading because there's a lot of different functions that are called this. There's not just one, but it's a start. It's definitely a start. What are we? How do we do it in the compiler? Apparently we don't. Apparently we just pass it through. Just looking to see how function handlers is built up. I guess it's here. It's either here or here. Oh no, that's a copy constructor. That's not going to be it. Define. Of course. Okay, it's define. It's define. I wonder, are we doing this correctly then? See, like, what is throwing me is this. I understand being a global. This lot seems a bit weird. Like, let me. Actually, we've got it in here, so we can have a quick look. Where's the script? So I can't physically look at the scripts in here because we've, this is a commercial director file that we've done an illegal mod on to open in the editor. So, there is no scripts. We just get the little cast member IDs. And Yeah, okay. So let's just pick one of these scripts. Let's pick script number 246. Because I'm pretty sure that's going to be defined as a... Yeah, it's a script cast member. It's not a movie script. I'm pretty sure a movie script is a different type. That's also a script cast member. Find cast members. Whose type is... Oh no, there's just... Okay. Okay. So, sorry, there's only one cast member type, but this is what I mean, where it says score script versus movie script. See, my expectation would be that this list here would only show things that were only in the movie script variety, as opposed to type, because if it was as opposed to score. Because if it's score, then that should be defined in here because you've attached it to a frame in the score. Like, yeah, in this one of these slots here. If you haven't done that, then that's not ideal. Oh no. Oh, and at the 2.5 hour mark of the stream, I realized that I might have left the NVIDIA flag on, which causes a whole bunch of glitching on the video. So really sorry if it's showing up as like kind of, I don't know, frame skippy. It may not have been. I haven't seen it with my own two eyes, but if it has, I'm sorry. I didn't intend that to happen. And yeah. Okay, that's good, Varventlar. That's good. Because I don't know, I've had like bad luck in the past where if I haven't... really regretting buying a NVIDIA card now because it's such a... Yeah. I've got... Yeah. So with NVIDIA, there's this kind of issue where if you have an accelerated desktop going on and you don't have power misers set to like the waste as much electricity as possible setting, sometimes that'll mean that the screen recorder will glitch out and show like weird tearing artifacts. I'm encouraged by the fact that from like the few minutes I was looking at it, I couldn't see it. Usually you see it immediately if it's busted, so that's reassuring news. Anyway, back to this. Yeah, so I'm not sure of the best way to kind of go about doing this. Maybe once we've gone and maybe later on when we've gone and rigged the cast member printout method to print out exactly what type everything is, or just kind of more information about the type, which would include movie script, we could then go back and confirm. Because what I'm thinking, right, is I'm thinking that maybe we've just been too permissive all along. Maybe we should only be adding into this archive stuff which is marked as movie script, because it should be being included as a frame function instead. And it's just something that we never kind of look, you know, because we had no visibility on like what the function list was, we just never noticed that was an issue. And, you know, 9 times out of 10, you won't really notice, except, you know, if you try and do something like call exit frame on a frame which doesn't have it. and it works. Anyway, okay, so this movie's maybe not the best example. Let's go to Eastern Mind, which has a ton of movies. Okay. So we'll go to the face, which is a bunch of things you can click on. Okay, so we can see we're on frame 4, and if you go funcs... Okay, interesting. So no frame functions. Is that because we're not on a script? Yeah, right. Oh, we haven't printed the shared ones yet. I was wondering, like, there should be like a ton of stuff, but no, that's because it's all in the shared cast, which we have not printed yet. We should though. We should print it all. Later on we can move all this stuff into the cast object like we did for that other one, but for now we're just prototyping. You're allowed to be messy when you're prototyping. So we'll just rebuild that. Yeah, all right, that's better. So we have, yeah, we've got just the functions that are in our movie, and then we've got the ones that are in the shared cast. And good lord, there are a shocking number of them. Yeah, including generic ones like mouse up. How can we make the debugger testable? I don't know how to answer that question. I think... Yeah, no idea. I guess you could go ahead and like... I mean, I guess, yeah, you could go ahead and like make a test movie, which... and then feed a bunch of commands in, and then confirm that the commands match an output point. Want to say that such a thing is beyond my skill set in terms of like instrumenting C++ to do that. Maybe if I like spend a bunch of time thinking about it, but really like this isn't a load-bearing part of the director experience. So I'm less concerned about this than I am about regression testing. So if the debugger breaks, if you kind of smack it around too much, it's fine. Can live with that. All right, well, that's a good... I'm pretty happy with that. It could be better, but... So there is a temptation to move all of this into a method that's on cast. And that wouldn't be the worst idea. What else we got? This is pretty tempting. So, I don't know. The reason why I've been putting this particular one off for a while is not because disassembling is hard. Like, disassembling is something we already have. Like, we already got the code in lingo.cpp. Oops. Yeah, which you can already see, like, if we step to a script thing, you can see that we disassemble the first instruction that we come into contact with, and it's pretty trivial to just disassemble everything that's in the script, which is more or less what the verbose mode does. The tricky part of that is not... So the tricky part is not the hard-sounding thing. It's actually the easy-sounding thing of turning this into a resolved function name. Because, as we can see here, we have three different sources of function definitions. We have the one that's in the frame, we have the one that's in the cast, and we have the one that's in the shared cast. Which makes me think we might have to, like, do some kind of, like, maybe at first arguments, like disassemble frame, disassemble cast, disassemble shared cast, but that's also irritating. It would be nice to just have, like, it would be nice to just have one which doesn't need a qualifier, which means that you should be able to just try any of them. Or you could be more specific if you want. And that also makes me think that maybe on the cast, or actually not on the cast, on the movie? Yeah, on the movie. Yeah, it'll have to be the movie, because, yeah, on the movie we should probably have some kind of, like, get function from ID, where ID is, like, you know, cast colon whatever or integer colon whatever, like just move that logic out of here and into movie. That's kind of maybe moving forward a few extra steps. Hang on a moment. All right, we've hit the 3-hour mark, so I think I'm gonna call it there for today. We've made some fun progress. In fact, I am going to, yeah, let me just commit what I've got, and then we'll do a raid on somebody else. Cool. Yeah, okay. So I think, yeah, the next step is I'll go back, have a little think about how I want the function resolution stuff to work, and then we might do one more stream. You know, once we've done that kind of thinking bit off air, we'll come back and we'll do one that's about breakpoints. And then we should have a proper debugger. So anyway, thank you so much everyone for tuning in. We are going to raid Sharble Garble. She is about to play Power Wash Simulator. Oh my god, such a lore-filled stream. Enjoy the rest of your evening, everybody.